Hi everybody, this is Mrs. Yinny, and I'm going to go through problem 3.2. In problem 3.2, you are basically just extending problem 3.1, where you looked at one-on-one situations in a basketball context. And in 3.2, we're going to take that one step further and find the expected value. So the first thing that you're asked to do is analyze the free throw percentages of several players that are in a one-on-one free throw situation. And so you can see that I've completed 3 of these area models right now, and I'm going to go ahead and complete the 4th and then find the expected value for both of these. So you should have been doing this with your 3.2, and you should have this worksheet in your folder. Okay, so an 80% shooter means that they have an 80% chance of making the first shot. So I'm going to draw a line here at 80-20. That means a 20% chance of missing it. And remember, in a one-on-one situation, if you miss it the first time, you don't get a second shot. So that's why I make this a 0 points. But if they do make it, which is this section, they get a second shot. And again, they have an 80% chance of making it. So this big section right here would represent that they made it to start with and that they made it the second time as well. So that would represent 2 points. This section represents that they made it to begin with, but they missed it the second time around, so that would be our 1 point. So the probability of 0 points here would be 20%. Probability of 1 point is this section here, which is 16%, and this section here would be 64%. Okay, now what I'm going to do is I'm going to transfer this information to the table below. 60% shooter is this one right here, and I haven't transferred all this information yet. The probability of getting 0 points was 40%. Probability of 1 point, this is 6 by 4, so that's 24%. Probability of 2 points is right here at 36%. Alright, and so the expected value I still need to calculate, so let's do that together. So my expected value, I'm going to take my 0 points, and I know that out of 100, because of course expected value is your long-term average, and we're looking at 100 as our long-term average. So 0 points is going to happen out of 100 times 40 times. So 0 times 40 is 0. You're going to expect to make 1 point 24 times, and 1 times 24 is 24. And you're going to expect to make 2 points 36 times, and 2 times 36 is 72. So when I add that together, I get 96 points. But that's out of 100, so we have to divide that by 100 to get our expected value, which is our points per attempt at 0.96. So I'm going to fill that into my chart here. Now let's do the same thing, find the expected value for an 80% shooter. We're going to expect them to make 0 points 20 times out of 100. We're going to expect them to make 1 point 16 times out of 100. 1 times 16 is 16. Make 2 points 64 times out of 100, and 2 times 64 is, and then our total here is 144, and we're going to divide that by 100, and so our average points per attempt here is 1.44. So I just realized I need to enter all that information down here. So an 80% shooter, there's a 20% chance they'll make 0 points. There is a 16% chance they'll make 1 point. A 64% chance they'll make 2 points. And expected value would be 1.44. Alright. 100% shooter. So let's look at this information here. 100% shooter. Probability of scoring 0 points if you're a 100% shooter would be 0%. Probability of scoring 1 point if you're a 100% shooter would be 0%. Probability of scoring 2 points if you're a 100% shooter would be 100%. So if you're going to score 2 points 100% of the time, then your expected value would be 2. In other words, every time you're at the line, you're going to make every shot that you make. 0% shooter, probability of making 0 points is going to be 100%. Probability of scoring 1 point will be 0. Probability of scoring 2 points would be 0, and your expected value then, of course, would be 0. Okay, let's move on in the problem then. So in part C, you're asked to make a graph for each player in the table. So what I'm going to do is I'm going to take this information that I've already calculated on my expected values, and I'm talking specifically about this part of my table, and I'm going to use this information in my graph. So I know a 0% shooter has an expected value or average points per situation of 0. I know my 20% shooter has an expected value of 0.24, so it's going to be about right here. My 40% shooter has an expected value of 0.56, about right here. My 60% shooter, just under 1, about right here. And the 80% shooter is about 1.44. So let's see, that's 1, about right there. All right. And so that's what you have. And if you'd like to kind of connect that, you kind of get this sort of trend in your line. All right. So let's go to number 2. So how does the average number of points, compare for all players? Well, the average points per trip increases as the player's average increases. So let me write that briefly. The average points per attempt increases, and we can see that clearly in our graph, as the player's average increases. Okay. Nishi's dad has an expected value of 1 point. So what do you think his free throw percentage would be? Well, if his expected value is at 1, we know that it's going to be a little bit greater than 60%, because 60%, remember, that was at 0.96, and if he is at 1, just above that, we would know that it needs to be a little more than 60%. All right, number 4, Nishi's sister has a 70% free throw average. What is her average points in a 1-on-1 situation? So you might want to use an additional area model, and that's what I have here. So she has a 70% average, so of course I'm going to separate my area model into 2, 3, 4, 5, 6, 7. Uh-oh, I'm one too big here on my area model. You might notice that. Oops, I just cut off the wrong side. That's right, I'm going to do it on the... I'll do it right here. So just ignore that line that I have drawn. 1, 2, 3, 4, 5, 6, 7. And so 70% means there's a 70% chance of making it and a 30% chance of missing it. So I'm going to do the same thing over here. She has a 70% chance of making it and a 30% chance of missing it. Alright, so this is where we start, of course, when we make our area model. Now let's use this information to calculate her expected value. Alright, so her points percentage, 0, is at 30%. And if I expect that out of 100, I'm going to make 0 points 30 times. That's 0 points. Her 1 point is at 21%. And so I'm going to expect that 21 times out of 100, I make 1 point, and I get 21. Her 2 points, I'll put that over here, is at 49%, so I'm going to expect that 49 times out of 100, she'll make 2 points, which is 98. So now I'm going to add up my 98, my 0, and my 21, and I get 119. I'm going to divide that by 100 so we can get our average points per attempt. And so we would expect her to make 1.19 points per attempt, per time at the free throw line in a 1-on-1 situation. All right, I hope that helps everybody. If you have further questions, make sure that you see Mrs. Yenny, and have a good one.